Segment 1. The Birth of a Monster. How Tornadoes Form. Every tornado begins as a storm, but not every storm becomes a tornado. For one to form, the atmosphere has to be just right. Warm, moist air from the Gulf of Mexico rises and meets cool, dry air from Canada. When these two air masses collide over the central United States, a region known as Tornado Alley, the atmosphere becomes unstable. Inside massive thunderstorms called supercells, wind speed and direction change rapidly with height, a phenomenon called wind shear. This creates a horizontal spinning effect in the lower atmosphere. Then, powerful updrafts tilt this spinning column upright, forming a mesocyclone, the birthplace of a tornado. When the rotation tightens and stretches downward, a visible funnel cloud forms, and once that funnel touches the ground, it becomes a tornado. From that moment, it's pure chaos, a violent dance of wind and debris carving a path of destruction across the landscape. Segment 2. The Fujita Scale, measuring the unthinkable. So, how do we measure something so destructive? We use the Enhanced Fujita Scale, or EF scale, created to categorize tornadoes based on the damage they cause. EF0, 65 to 85 miles per hour winds, broken branches, flipped signs, light damage. EF1, 86 to 110 miles per hour, roof damage, mobile homes destroyed. EF2, 111 to 135 miles per hour, entire roofs ripped off, cars thrown. EF3, 136 to 165 miles per hour, walls collapse, trees uprooted. EF4, 166 to 200 miles per hour, houses flattened, cars thrown like missiles. EF5, over 200 miles per hour, complete destruction, only foundations remain. An EF5 is so powerful it can rip asphalt from roads and debark trees, literally stripping the landscape bare. When meteorologists survey tornado damage, they look at the aftermath, the debris patterns, the structural damage, and the total obliteration. Because when winds move that fast, there's no direct way to measure them in the moment. Instruments just don't survive. Segment 3. The Human Scale. The toll on lives and cities. Statistics don't do tornadoes justice. A single EF4 or EF5 can level an entire town in minutes. Homes, schools, and hospitals gone. Families torn apart. Lives changed forever. Take the Joplin, Missouri tornado of 2011. It struck on May 22nd, an EF5 that cut a mile-wide path through the heart of the city. Winds reached over 200 miles per hour, and more than 160 people lost their lives. It became one of the deadliest tornadoes in modern American history, or the Tri-State tornado of 1925, the deadliest in U.S. history. It traveled over 200 miles across Missouri, Illinois, and Indiana, killing nearly 700 people. That's not just power. That's history written in devastation. For survivors, the memories last a lifetime. The roar, the darkness, the eerie calm that comes just before impact. Tornadoes are more than meteorological events. They're deeply human tragedies. Segment 4. The Science of Destruction. What tornadoes actually do. So what makes tornadoes so destructive? It's not just the wind. It's what that wind does. When rotating air tightens, it behaves like an ice skater pulling in their arms. The spin speeds up dramatically. Inside the core, pressure drops fast. That drop is so intense, it can make houses explode outward, not inward, as the higher indoor pressure pushes against the collapsing walls. Then there's the debris. Everything becomes a projectile. Wood, glass, cars, even concrete blocks. At 200 miles per hour, a 2x4 plank can pierce brick walls. A car becomes a missile. And here's what's wild. Tornadoes don't just destroy randomly. They can skip across the ground, obliterating one house while leaving the next untouched, creating patterns that almost defy logic. That's the chaotic, unpredictable nature of fluid dynamics at play. Segment 5. Tornado Alley, America's perfect storm. If there's one place in the world synonymous with tornadoes, it's Tornado Alley, a region stretching across Texas, Oklahoma, Kansas, Nebraska, and parts of the Midwest. It's where the perfect ingredients for tornadoes mix like clockwork. In the spring and early summer, warm, moist air from the Gulf meets cold, dry air from the Rockies. That contrast fuels massive supercells capable of spawning multiple tornadoes in one outbreak. But here's what's surprising. Tornado Alley is shifting. Recent studies show more tornadoes now hitting areas farther east, like Tennessee, Alabama, and Mississippi. Scientists call this the Dixie Alley shift, and it's concerning because these regions are more densely populated and often hit at night, when people are asleep and less likely to hear warnings. Segment 6. The outbreaks, when one tornado isn't enough. Sometimes the atmosphere doesn't stop at one. It creates dozens. The super outbreak of 1974 saw 148 tornadoes tear across 13 states in less than 24 hours. It remains one of the most intense outbreaks ever recorded.
Then came April 2011, when 360 tornadoes ripped through the southern United States in just 3 days. Over 320 people died, and entire towns in Alabama were wiped from the map. These outbreaks remind us that tornadoes are part of a much larger system, a chain reaction of energy, moisture, and instability that can stretch across entire regions. When the atmosphere decides to unleash chaos, it doesn't hold back. Segment 7. Tornado Myths versus Reality. Tornadoes are terrifying, and with that, fear comes myths. Let's clear a few up. Myth 1. Open your windows to equalize pressure. Reality. Don't. It wastes time and does nothing. The pressure drop is so fast it won't matter, and debris can enter your home. Myth 2. Tornadoes can't cross rivers or hills. They absolutely can. Terrain barely slows them down. Myth 3. Highways and underpasses are safe. Segment 8. Forecasting the fury. How we predict tornadoes. The good news? We're getting better at predicting tornadoes. Meteorologists use Doppler radar, satellite data, and computer models to spot rotating storms before they touch down. When a supercell shows signs of rotation, a tornado warning is issued. 50 years ago, warning times were often less than 5 minutes. Today, we can often give 15 to 20 minutes, and that difference saves countless lives. But prediction is still difficult. A storm can show all the right signs and never form a tornado, or a weak storm can suddenly spin up a deadly one in seconds. Segment 9. Surviving the unthinkable. What to do in a tornado. When the sirens go off, every second counts. If you're at home, go to a basement or an interior room on the lowest floor. Stay away from windows. Cover yourself with a mattress or heavy blanket. If you're outside, get to a sturdy building fast. If there's none nearby, lie flat in a ditch or low area and protect your head. Never try to outrun a tornado in your car unless it's far away and moving parallel to you. Segment 10. The strange beauty. Why we can't look away. Something is haunting about tornadoes. The structure, the symmetry, the sheer power. It's horrifying, but also mesmerizing. Photographers risk their lives to capture the perfect shot of a funnel cloud twisting against the horizon. For scientists, each tornado is a clue, a step toward understanding the chaos of our planet's atmosphere. They remind us how fragile we are, and how small, standing beneath the raw force of nature. Tornadoes don't discriminate. They destroy everything in their path.